Hello, everyone. This is Bill Acevedo, and welcome to Dell Networking OMNM Tech Talk. In this session, you're going to see a new feature. It's going to allow users to basically plug in to an access port and have that access port be automatically configured with the appropriate VLAN. This is just an example of one of the many capabilities we have through automation. We're referring to this port as automatic port configuration. Other features that you're going to see in this demo are events, alarms, event processing rules, and actions in ACLI. We're going to get into some advanced concepts with the EPRs, event processing rules, and there's some advanced features on ACLI we're going to show. So if you haven't reviewed those videos, I would recommend reviewing those other videos that are also available online. All right, with limited IT budgets and staff, wouldn't it be great if an IT admin did not need to be involved every time a new device is plugged into the network? What if OMNM auto-detected a plugged-in device and auto-configured that port with the proper VLAN? And this would provide immediate connectivity to the user. Now, it could be something like a printer, it could be a laptop, it's another switch, and so maybe I'll be on different VLANs, and I'm going to show you how the switch can automatically make some determination of what that is, and with a little bit of logic, and auto-configure that VLAN. So again, we're going to show the ability to plug in a new device's switch, a managed switch, an N4064, and we're going to have OMNM auto-configure the managed switch port with the VLAN assignment. Okay, let me scroll this down just a little bit here. Prior page. So in this case, we're going to demo two cases. And so part of our determination of what's on the other end of the link is going to be using LLDP. And then there's cases where we're going to also not have LLDP configured. For example, in the case of a laptop where the other end of the link's not going to understand the LLDP protocol. And so in this case, case number one, I'm going to use this managed switch again. I'm using this port TE1029, and I just want to show you that here. Slide that over just a bit. I want to show you on 1029. I'm going to do a show run interface on 29. And so what I'm showing here is that the switch is currently in shutdown mode, and it's got LLDP configured. And I'm going to be using, in order to simulate a link up, rather than going and plugging something into the lab, manually, I'm going to use a shutdown and a no shutdown to control that. And I'll show you how that's going to work in a minute. But let's look at the other one while we're here. In case two that we're going to use, port 30, it also has LLDP on. It's also in shutdown mode. So you'll notice there's no access VLAN on here, no description. It's just basic empty port waiting for something to be plugged in. And so these cases 1 and 2 here that I have listed here describe what we're doing here. And again, we're going to set on 1029 configuration. We're going to set a description. We're going to plug something in. In the first case, it's going to be another switch that understands LLDP. And we're going to auto-provision a description on the port saying auto-provision port VLAN from OMNM, and we're going to put access VLAN 4000. Okay, sorry about that. Scroll down a little bit there. Go back to that page. Getting ahead of myself. In the second case, we're going to use port 30, and this time it's going to be connected to a laptop which doesn't understand LLDP, and we're going to have a known MAC address. We could have a series of MAC addresses we know might plug into that port, and we can base some logic on that. And in this case, we're going to use the MAC address to determine what VLAN should be configured. And if it fits the VLAN, or if it's the list of MACs that we want to allow, then we're going to automatically, this time, provision port VLAN 3000. Now, before I get into this, I want to say this is a two-stage process, and this is where we get into a little bit more of advanced processing rules, advanced event processing rules. So there's going to be two stages here. Stage number one, EPR1, that I'm designating here, is basically a response to a link-up trap. So the user is going to plug in a port, and the automation trigger here is a link-up trap comes into OMNM. Now, this is on the managed switch. So the managed end is going to send us a link-up. That is going to invoke another process that's going to go collect data on that particular port. And so you see here there's this action that's called link config up. it's going to automatically call that action and go and collect data, for example, CDP, LDP, EDP, or MAC data, and some other algorithms to determine if there is what's on the other end of that port. And it's going to try to collect some data. And so it's going to create another notification, and this notification is going to contain all that data. So that notification can then be sent to EPR2, which the user then creates to basically create their own custom EPRs for what VLANs or what configuration they want to put on the switch. So in EPR2, you'll see that we have the LDP, CDP, MAC info being passed in. The user is going to create that EPR that's going to be triggered by that link config up notification. And you're going to set filters based on the data that's collected. And there's going to be things like sysname, sysdescription, systype, chassis ID, which is basically the MAC. And you can make determinations on that to determine, hey, if it fits this category, this name, or this description, then go ahead and provision a specific VLAN. And that's an action that you would have to create also as a target of EPR2. So that's what I mentioned in the last part here. The user creates a new action as the target and sets the port attributes to be passed to the action script. What this last part means, so basically we're getting a link up trap that's on a specific port. And we want to be able to send configuration back for that specific port. In order to gather that information from this link up trap and the var bind, they call it a var bind in the SNMP variable, that data is in there. We just need to collect that, and we do collect that through this process, but then when you pass that to EPR2, we need a way of gathering that port data and passing that actual name, for example, 10 gigabit Ethernet 1/0/29, pass that string to the action so that it knows which port to act on. I'm going to show you that in some detail here. So let's just go ahead and do a quick example here so I can show you how this works. And so let me bring up my system here. Okay, so here I have my example of my event processing rules, and I've labeled these specifically so that you can see what I'm referring to, EPR1 and EPR2. So in the first case, I have EPR1 that we expect to be invoked when a link up trap comes in, and I'll just show you that real briefly here. And so this is a preceded rule that you don't need to modify for the most part. It is basically set to trigger on a link up. Now you may have other things you want to trigger this particular process, but in this case it's set to a link up. And if you want to set filter condition, meaning you don't want every link up that comes in to trigger this, then you'd want to filter that to say I want only on this set of switches for this to be activated, or a set of ports. So you could add that filter down here. And then so as I was showing, it calls this action called link config up. This is the one that goes out and processes the link up notification, emitting that secondary event after it collects all the data. There's no need to modify this area here. You want it to go collect that data. But then the second part is, it's going to go and do something to the switch based on that first one here. So let's look at one of these, for example. This demo one is here for the first case where we attach a switch to the port. Just edit that one and look at it. And what you see here, that's just a basic naming. And so here you see the link up config is the event definition that it's going to be triggered on. But in this case, we're going to say, and this is the data that's going to collect. And I'll show you some more details on this, but this is the new data that's been introduced. So we're going to be passing in what's called the link config local port CLI name. This is something that we get at discovery time for the device. So this is how it's going to know the name of the port that's being passed in. And then we've got remote chassis ID. This is where it goes out and collects data about the MAC ID or chassis address. Same thing for the system description, system name, or system type. So these are the primary ways that we can trigger different information from that port. In this case, what I'm saying is remote sysname. I'm saying if the remote sysname, the remote device, if I learn through LLDP that it is a specific device, then I want to proceed on to the action of this EPR. And in this case, I'm saying if it falls into one of these switch types in a 6000, 4820, S6010, or S5, now you can do anything you want here in terms of name, and this is just one example. And so if it fits this filter condition, then it's going to go on and execute the action, and I'm only interested in this top action here at the moment here. So what I'm showing here is that the target of this action is another, and I'll show you this, it's called force 10 set access VLAN to 4000, meaning if it's one of these switch types that I've already put in the filter, then go ahead and provision for VLAN 4000. Now this part down here is an attribute that is part of this action up here. This is how I pass in the port name. And I'll show you this in just a little bit more detail, but this is the explicit syntax that's needed. This is the var bind information that comes in from the link-up trap. And more indirectly, it's the port CLI name that gets passed in on this var bind. So you need to surround it with these 2 square brackets and this var bind name. And I have those listed in this demo, and I'll show you those. So let's go look at that action on what's getting passed in here, actually. Okay, cancel that one. And down below, I have an actions portlet here. So let's look at that one for the force 10. Okay, the main part of this here is the script of what it's doing. So you can see here, I have a couple of diagnostic scripts so that when I run this manually, I do a show running config on the interface before and a show running afterwards so I can see the difference. But the meat of this action is we're going to do a config T, and we're going to do interface, and we're going to pass in this port attribute, and I'll show you that, how I set that up. This is where it's going to say interface TE1/0/29 or TE1/0/30. And that's going to set the description on the port, it's going to set the VLAN on the port, it's going to exit and exit out. And so that's a very simple thing. And so let's go back here and look at the port. The port value is a simple attribute. It's just a string value that I put in here. And there's no other details other than I created it and called it a string. I gave it a label of port. And so this is that attribute we saw in the event processing rule that we were passing through. Okay. It's going to be a similar case for, I'll come back to this one. Let's do the first one first, and we'll come back to this one. So let's just go ahead. I'm going to go actually to my alarms portlet. Or did I have that here? Okay, no, we'll go back to that one. I have this filter to just filter for specific events. So what I'm going to do here, what we're going to see, is I'm going to go to this port TE1029. So I'm going to go interface TE1/0/29. And I'm going to do a no shut. Now, so this is going to mimic somebody plugging in. There's already something plugged in there. And so this is going to mimic the link-up trap that you get when it detects that there's something there. We do no shut. And so what we're going to get, slide that over there, we get a link up. So this link up is now being triggered by the first event processing rule. The link up comes in, it's going to go back to that port that came in on that particular event, and it's going to go interrogate it for information. And then it's going to admit that secondary trap. And let's just give that a second here. It does take a second or two, probably up to 30 seconds, maybe up to a minute to go and get that data and return that information. Okay, now we see that this link config up notification has come in, and so what now is happening is this link config up notification has now triggered the secondary event processing rule that's going to say, is this the right kind of switch? And if it is, go ahead and provision the action to set the description and the VLAN on that port. So now let's go look at that 1029. Just going to do a show run interface here. Oops, that's the wrong one, 29. Oh, there we go. So we see the description has been applied to the device and is now on switch port access VLAN 4000. So that seemed to work just fine. Let's do our secondary. Actually, let's dive into this just a little bit here. I'm going to show you this on the PowerPoint slide I have as well, but you're going to see here, I'll look at the details of an event, and you can do this on any event, by the way. And what you're going to see is the actual var binds that are part of a standard link-up trap. And so you see here we get if index 29, and this gets translated into that port name, the port CLI name that we're going to see. So let me go back here. And let's look at this event. This is the one that went out and collected all the data. Details. So now we see some of those parameters that we discussed. Link config local port CLI name. So now it shows the port. And the remote chassis ID, we collected a MAC. The remote system description, there's a long description here that it will, you can fuse any part of this to filter on for your action. And in this case, it found the link config remote sysname is an S4820. And so this was one of the this is one of the switches that was listed on our filter criteria. So that's why it invoked the action. So that's how that worked. Let's go look at the next one here. Let's go to the laptop case. And so in this case, again, you see up here on port 30, we have it's done shutdown mode again, and it's got LLDP on it. This time we're going to plug in a laptop. There's already one plugged in there. I'm just going to use the shutdown command, or no shutdown command, to mimic a link up. Shut. Go back to our alarm screen. We'll look at that, and there's our link up came in already. It's going to invoke that first EPR so that we can emit another link up config notification on that specific port. Okay, and so now you see that link up has come in now on the port 30. Again, we can look at that. It's going to have some slightly different information. It's not going to be able to collect LLDP information. And so there's going to be some things missing, but you do see that we still have the port CLI name, and then we've also got the remote chassis ID, and now we have this MAC address. So remember, this one ends in 8D2C. And we'll go look at that secondary rule. But first, before we do that, let's go look at our port and see if it worked. So what we should see is another description, but with a different VLAN. And we'll look at 30 this time. And sure enough, there you go. We have the description again, and we've gotten this time it's access VLAN 3000. Okay, so that seemed to work just fine. Let's go look at that one just to see how that worked in a little bit more detail. So again, this is the event processing 1 kicked off. This time it invoked event processing 2. And let's go look at that one. Look at our filtering again. We're just filtering on this link config up notification, but this time we're saying if the chassis ID is in a list of chassis IDs. And here's that one, 8D2C. And so we're able to say that if it fits this filter condition, then let's go ahead and pass it on to the action. That's part of this event processing rule. And this time the action is to port PC set access VLAN 3000 this time. And again, I want to show you that the port needs to be passed in as well. The script is the same, except for it's a different VLAN. It's not the exact same script, it's a new script, but I'll show you that. But that's a target there, and the var bind information is now being passed for that port. That needs to go into that attribute on our action. And I'll show you this in a little bit of detail here, just a second. So let's go look at the action. So here's our action down here, and this is the action that got called, the PC set access VLAN, and let's just go and edit that. One thing I do want to point out is that these actions have a target type of port. You can have target types of different elements here, equipment subcomponent interfaces, managed devices. Typically, if you just say managed device, it'll be available from the right-click menu on the resource manager, and it's just going to go as a managed device and apply that action. If you want it confined to just a specific port, meaning you want to go to the port's portlet, or in this case up here, the interface's portlet. Our case today is ports. You could actually go to the port's portlet directly, right-click a port, and this action will be available to that at the port level to push that out there. And so you can select the port specifically and want to specify it. But anyway, it's the same thing here. I've got a simple port attribute here, and then I've got a script that's nearly identical. Okay, and so you see here that we have the same thing, the before configuration. I got config T, and again, interface port. I'm just setting the description, and then I'm saying switch port access VLAN 3000, and then running it again. So that's really as simple as it is there. And so let me just show you also one other little thing here that might be of note here. So in the actions portlet, you can always go to the history on these particular things, and I can just show you here an example here. If we go to history, we see how many times it's been executed, and we can actually go in and look at this, and it will show you the exact commands that were sent. And this is the result of the commands here. So what you see here is my show running config interface, and where it interjected the port for our attribute, and basically it's showing nothing here first. Then we ran our config T on the interface, did the description, set the switch port access, and then at the end of this one we ran that same script again. Now we see where the description set and the switch port access VLAN is set. So we're just kind of validating the script all at the same time for review purposes. If you ever want to know if it actually got provisioned correctly, you can see that it did. Kind of a cool feature. You can also see the sent commands directly here. You can see the port attribute has been populated here, And then if you want to see parameters, you can also view that as well in terms of the actual attribute and the value that was set. Okay, in a nutshell, that's the demo part of it. Let's just go into some detail here so you can refer to this video and look up any of these items that you wish to later on. And so, as I mentioned here, the EPR2 from EPR1 will take the varbind information from the link config up notification and use this data as the EPR filter criteria to determine if the target action should be executed. So these varbinds that I listed here, there's a little bit of detail here on how they get populated. And so, for example, the config remote sys type. So this is, if CDP is working, then this will be populated showing the remote device type. Only CDP populates that. So if it's not there, you're not going to see it. The remote chassis ID. This comes from number 1, CDP, and number 2, LLDP. And then number 3, it also can come from, if there's no, neither one of those are running, we'll do some interrogation to populate that MAC address. The port local CLI name. This is basically what we get from discovery time, so that when the if index comes in on a link up, it knows what it's going to translate that to the port name, so we can use that. And that attribute can be filtered on also, as we just saw. Sys description. Paged up here, should not have. Page down. System description, this data comes from LLDP only. And then link config remote sysname. The sysname comes from number 1 CDP and then number 2 LLDP. And the last one here, remote sys type, this data only comes from CDP. So just be aware of those parameters. If you're not seeing data, it could be in these cases where one or more of these protocols are not on. So I want to give you an example. I've already shown you this, an example when I right-clicked on an event and you see the varbinds. Here's an example of some sample varbinds you might see. This is a Cisco example. In this case, I think it was running CDP. And so you'll see this data, and here's the bindings that you'll see in the details panel, that type of data. And so again, you can filter on any of this data in terms of how you want, if you want that passed to the action or not. You can use any of this data to filter on that. Okay, and in some cases where the varbind data is not found, you may see this actual attribute, this square brackets actually passed in as the value. That just means you did not get the data. That only happens in some cases, but I want to point out here is that if you wanted to pass the attribute of port CLI name, that recall that TE101/0/29, you need to put this, pass this from the EPR target ACLI. You need to pass it in this particular format. So you could pass other attributes to your script but you'd still need to use this syntax here. I think I have an example on the next page of how to, again, just to remind you how to set that up, or I thought I did. Okay, on this page I have it. So this is an example of this. If you want to refer to this page, it's in your EPR and the target action. And so you're going to click on this little page icon here, and this is where you set your, again, in my case, it was just a port attribute that I was sorry about that. You can go back up here. I have a port attribute. I want to pass the string value of the port CLI name. So I put in the varbind for the port CLI name here. That will get passed to my action. So this is just showing you how to set that up. Something you can refer to later if you need to. I think I missed a page here. Oh, I wanted to provide some actions, some examples here of what the filter criteria you can use when using these different parameters. And so one example is if the action is to be performed on devices with sysname, and so that's looking at this one here, the REM sysname, and say it's, you only want it to act on a force10_S4810, the EPR filter condition would show link config remote sysname, and then you can use logic like in or contains or begins with or like force10_S4810. And that's, again, that's the filter criteria that's on the event processing rule itself. So you can use that kind of logic. Or for an example here for systype, if the systype contains N3048P, you could set that in your filter type. Or another example is for chassis ID, as I showed you an example of a list of MACs. All right, just want to outline lastly here some of the key points here. The OMNM automatic port configuration configures ports at the OMNM software level. Unlike other implementations that you may see out there, the connected device is classified by the OMNM software and not through configuration or macros that need to be pushed to every managed device. That gets a little bit cumbersome when you've got to go out and manually push a specific macro to one or more switches, and then you got to worry about managing them that way. This way, it's all in OMNM, and OMNM handles all of that. Any number of rules, event processing rules, can be set to make sure the right configuration is applied to the port. And then an event can trigger one or more EPRs to perform an action. And so I don't think you have to do what's a one-to-one. It can be 1, 2, however many you need. And then an EPR can also perform an undo action. For example, if someone unplugs that port or gives a shutdown where you get a link down, you may want to delete the port configuration so that nobody else can connect to that. Or if somebody new comes in, it's going to behave properly. So there's a whole host of things you can do with that automation framework. And so that pretty much wraps it up, and I hope this was useful, and thank you for joining.